Hey guys, welcome back. Sorry it took me so long to get the rest of these videos posted. It is like 7 p.m. on Sunday, and I know my life said that it would be posted on Sunday morning. Sorry about that. I had a lot going on, and I decided to go and actually paint the wall of my twin brother's house. He wanted a portrait on his wall, and um, I think most of you know that I have the ability to draw and paint, so I spent the day with my brother, and it was pretty cool because we never get to spend so much time together. So my twin brother, I'll tell you all about it next week. Anyway, this portion of the midterm review covers the real number system, and I know everybody hates this part, and I really think it's because of like this whole Venn diagram thingy. So I'm going to break it down to you the way I did in class, so it's easier to remember what's what. Okay, so we have to look at it like this. For the real number system, okay, remember that all numbers are real numbers. And that's why you have real numbers on the outside of this box right here. So real numbers are rational, integers, whole numbers, natural numbers, and irrational numbers. All numbers are real numbers. Don't let that fool you, okay? Let's first talk about natural numbers. Natural numbers, the way I like to remember it, are numbers that we naturally begin counting with. Think of babies. Think of babies. When we teach babies how to count, we start saying things like 1, 2, 3, like that. And babies will repeat back 1, 2, 3. You know what I'm talking about. Stop cracking up at me. So these are natural numbers because we naturally begin with the number 1. When we add a 0 to it, see the difference? Natural numbers except with a 0. We then call it whole numbers. That is the only difference between whole numbers and natural numbers, is that whole numbers have a 0. And so we don't naturally start counting with 0 like when we're teaching babies how to count. We don't go 0 and then 1. It ain't right. So we actually call the without the 0 natural numbers. When you actually put a 0, when you start counting off, you are actually doing whole numbers. Okay. Now, integers. Think of a number line. If you see it on a regular number line, it is an integer. What's not integers are fractions and decimals, or percent technically are not integers. Because think of a number line, you don't really see fractions on a number line, you don't see decimals on a number line, you don't see percents on a number line, okay? That does not mean fractions can't convert into whole numbers and then be placed onto as integers, okay? So that's a little bit different, and you'll see that as we practice the sheets. So think of integer as a regular number line. Don't forget negative numbers and positive numbers, okay? Rational numbers. All right, here's the thing with rational numbers. Rational numbers can be fractions, they can be decimals, okay? And of course, rational numbers are also integers, they can be whole numbers, and of course natural numbers, okay? So whole numbers, okay, can also be natural numbers, because look, this matches, this matches, this matches, right? Integers can also be whole numbers because this side matches, etc. These three intermingle, and so does this one with them. That's why they're all on this side, okay? So rational numbers are all on this side because they like and tend to intermingle. Now, something clear about rational numbers though, okay? Rational numbers are numbers that if it's a decimal, because decimals will be in here, as you can see, and fractions will be in here. If it's a decimal or fraction, it has to be a decimal or fraction that can be converted to, like, let's say a decimal that either is repeating or has a pattern, or it has to be terminating. For example, okay, 3/5. What is 3/5 as a decimal? I always like to convert everything to a decimal so you can see it easier, right? So basically I'm asking, what is this as a decimal? And therefore you can tell if it's rational or not. So if I do this, 3 goes into 1, or 3 goes into 5 one time, that's 3. You have 2, add a decimal, add a 0, 3 goes into 20, 6 times, 3 times 18, 3 times 6 is 18, 2 left over, etc. 3 goes into 20, 6, and I think this will end up being repeating. Notice repeating. If it's repeating, it means it makes sense. A repeating decimal like this Okay, makes sense. Therefore, it is rational. Think about the terms and how we use them. Okay, rational because it is repeating and it makes sense. Also, decimals that terminate, which means they eventually end and don't go on forever. That's a rational thing to do. Rational means that it makes sense. Decimals that terminate make sense, so they are rational. Irrational, and I think I brought this up in the class, is more like, I compare it to my crazy Uncle Joe, okay? Irrational numbers are numbers that do not have a pattern. Look closely, it does not have a pattern. That go on forever, pi will go on forever, okay? Or does not make sense, okay? It's just kind of irrational, kind of like my crazy Uncle Joe. So he is irrational. There's no pattern, doesn't make any sense. Okay, so think irrational for numbers in that way, and hopefully with this little dialogue that I just spent giving you will help you have a better idea of what and how to categorize real number systems. Okay, now this worksheet is downloadable. Okay, so it's on the MyLab, and it gives you a practice of labeling what, because you have questions like this right on your final or midterm review. So let's go ahead and take a look at this. All right, so the first thing is, let me see what page it is and where we are. Okay, in the interest of time, I say if you change everything into a decimal, you'll be able to see if there is a pattern or not, and making everything easier to label. But first, let's take care of real numbers. Remember what I said? Every number is a real number, etc. Okay, so now, okay, the square root of 17. Now, if you have problems calculating square roots, that's when you do need to raise your hand and ask me to help you calculate those, since you guys are not using calculators, and also I'll be able to help you calculate imperfect squares, okay, because this is an imperfect one. So I would tell you that this is numbers like 4.12. Don't forget it's negative, okay? Now, here's the thing. It terminated, okay? This terminated, and it's a negative number. So I think that we are going to label this one as, it's not a natural number, it's not a whole number because it's got a decimal, it's not an integer, okay? It is going to be a rational number, okay? So number one is negative 4.12. It is going to be a I think it terminated. I need to go back and check on that one real quick to see if this. Okay, so I think they had a small mistake here. Let me continue with this one. Sorry, that was my phone in the background. This square root of 17 is not a perfect square, so don't forget I will help you with those. And this one actually does not terminate. There's lots more digits after this one, after the 2. So something like I think it was 1, 2, like 3106. So therefore, it's not actually a rational number because there is no pattern and is going to keep going on forever and ever and ever. So we're going to call this one an irrational number. So remember, crazy Uncle Joe, there's no pattern and it keeps going on forever, ever, ever, ever. Okay. Looking at the next one, I have a square root, or excuse me, a negative 2. All right. So here, let's see what we got. So negative 2, there's, just take a look at that. And what's it going to be? Now you think number line, right? You think a number line, you're absolutely correct. So this is going to be an integer. There you go. Okay. Not a natural number, not a whole number because it's on the negative side. So is it a rational number? It's a real number. And also an integer. I'm not sure, and I don't think it's a rational number. I'm gonna look at that one up just in case. So once I think about it, it's an integer and a rational number, because technically all integers are rational numbers. So since it's an integer, it makes it a rational number, and of course it's a real number. Now this one, if you convert this fraction to a decimal, you're going to get like 4.1111. You see a pattern. So let's remember, if you see a pattern, it's also a rational number, and of course everything is a real number. 0, be careful with 0. 0 is a rational number, okay, because you can find it on the number line. All right, and so 0 is a rational number, and of course you can include it as an integer. So negative 6.06. All right, negative 6.06. Notice it terminated 06. It terminated. There's no more numbers going after it, so therefore it makes it rational. It does not make it an integer because think number line. We don't usually see decimals on a number line. So we're going to keep this as just a rational number and of course a real number. So now you have 4.56. That sixth part is repeating. Remember, repeating things are rational. And of course, making it a real number. Looking at this decimal, you can tell it's going on forever, never, never. And so it is irrational. There we go. And so also remember too, natural numbers are whole numbers except zero. Whole numbers are numbers with zero. Integers, think number line. There are no decimals. There are no percents. And then rational numbers are numbers that are terminating, like whole numbers or negative numbers, and also terminating if there's a decimal that ends or has a pattern for a decimal. Irrational number, think Crazy Uncle Joe. So now we're at the number 18, and the number 18, oh my goodness, not only is it, oh my goodness, it's a national, it's a natural number, it's a whole number, you can find it on a number line, it's rational because it terminates, and of course it's a real number. So this one kind of hit all of them. So you have a sheet that gives you more of these type of questions, and if you actually print out the sheet for practice, skip number 9 on it, but the rest of them, 10, 11, 12, 13, 14, and 15 are on the worksheet that you can download here, and I give you the answers to the odd ones at the end of the page. I found this page on the internet, nicely done. But this will help you determine the real number system and how to categorize everything, okay? So one last part to this, and this part is on your worksheet as well, is this area of the worksheet, because you're going to have some questions like this on your midterm exam. And so you just have to answer true or false. All integers are rational numbers, okay? All integers are rational numbers. True. All negative numbers are integers. True. Well, no, I don't think that's true. If I really think about it, because you can have a negative number that is irrational. All negative numbers are integers, and so you can have a negative number that's a digit, okay, that's irrational, which we don't consider as an integer. So 3.87655, you can look at this and see that there is no pattern to it, so it's a rational number. I would say false. Square root of 7 is a real number. Yes, it is, because remember, all numbers are real numbers. All fractions are integers. That is false. Okay, so it gives you an idea of what's what, and I hope that was helpful for you, and I will see you on the next one. Bye, guys.